Good evening, everybody. My name is Jana Johnson. I am the program assistant with the NAPS program. My plans are dislanishne ani bashashin tenabitli dashache adniskini dashanale. So we're going to go ahead and start our webinar. With much planning and coordination, the Drought Management Webinar Series with 6 webinar sessions every week on Thursday at 5:30. Different topics will be presented. I want to thank everybody online and by telephone for joining us this evening. The Native American Producer Success Project is a collaborative effort between developing invocations in Navajo Education Incorporated, New Mexico Cooperative Extension Service, and the Dene College Land Grant Office. The project is funded by the USDA Office of Partnership and Public Engagement, Outreach and Assistance for Socially Disadvantaged Farmers and Ranchers, and Veteran Farmers Ranchers Program.
Hello everyone. I'm Helena Deswood. I'm the tribal coordinator with the Southwest Climate Hub. We are one in a network of 10 hubs across the nation working to support resilient agroecosystems and forested landscapes in the face of a changing climate. We operate in 3 functional areas: science synthesis, convening, and decision support. The Southwest Climate Hub helped to co-launch the Drought Learning Network. The Drought Learning Network is a consortium of climate service providers and resource managers and strives to share critical drought-related knowledge to build future resilience. Today we have Dave DuBois as our speaker today. He is the state climatologist for New Mexico, director of the New Mexico Co-Climate Center, associate college professor at New Mexico State University. He provides climate and climate change information and education to policymakers, the agricultural community, industry, educators, students, and the public. In addition, he also gives numerous talks and holds workshops every year on topics covering climate, drought, air quality, and climate change. Thanks for being here with us today, Dave.
All right, thank you. Thanks for the introduction. Hey, and my name is Dave DuBois. I'm the state climatologist for New Mexico, and I'm enjoying a nice warm day. I don't know about you, but it was pretty unseasonable today here in Las Cruces. We'll talk about the drought and kind of where we were, where have we been, and then we'll talk about outlook. So what's the next few months going to look like? So let's get started. Let's look at the past. So this is a map that shows the temperatures of the water year. So water year is the time starting in October. So it ends in September, and then another water year starts in October. And so this is October, November, December, January. And what we like to do is rank them, compare that the average temperature over that period compared to other October through January's over the last 30 or 40 years. And so what is shown here, so you can see all the yellows. And so a lot of the Western US, including New Mexico, Arizona, California, Nevada, were above average. So that's the top 33 percentile. And in few areas, it was actually much above normal. And you can see even some of the areas in the higher elevations in central and northern California were record warmest. So you can find out where you live and then see if that makes sense. And then this is the average temperature over those 4 months. And so we've been seeing well above average. And we've had kind of an average in January, although this past week or so has been particularly warm. But if you look at over the entire water year, let's look at the precipitation. So this is a same area, same time scale from October through January, and the same kind of ranking. So as you can see, a lot of yellows, so that's below normal. So let me move my little thing here so I can see. So that's the bottom 33%. And a few areas are kind of that mustard color, that's bottom 10%. So pretty much most of the areas are either in the below normal or much below normal. A few areas in Utah are the record driest over the current water year. So this is as of the end of January. So not a lot of good news in terms of late season precipitation. As we all know, we've had two really dry growing seasons, the monsoons. If you're in Arizona and New Mexico, we've had not very good luck with monsoons past couple years. We've had a few storms come in. We've had some episodic. We just like in California recently, they had some big events where they had dumped a bunch of rain, but overall it's been really dry. But just look at a few locations. So I like to look at these particular points. So I'm going to go across the state, go from north to northeast New Mexico, and go along the northern part, and then go in the northwest, and go into Arizona. And I'm going to just show you one station in. I don't know if there's anybody in like south central New Mexico. I'm going to show one station there, but I'm going to sort of go across from east to west. So starting over in the northeast part of New Mexico, we've got Clayton. And so all these maps show, these graphs show the accumulated precipitation. And so it starts in July 1st of 2020 and goes to pretty much about yesterday, today. And that smooth brown line, let me turn on my highlighter. So this brown line here, that's our long-term average. So we use these weather stations that have at least 30 years of data, and we compute the average on a daily basis. And then we sort of have a long-term average of the accumulated precipitation. And then the green line, the one that has like steps in it, that's the actual precipitation. So as you can see, if the green line is above the brown line, it's above average. And then if the green line is below that line, it's below average. So you can see for Clayton, we started off the growing season, the summer, above average. And we've had a few really dry periods in September all the way through the middle of October. However, we had a few rain events there, but we kept pretty much tracking pretty close to the long-term average. We only ended up just shy of a half inch below average, and that the total precip from July 1st at this location was just shy of 9 inches, so 8.95. Last year was much drier. And so let me go a little further west and then go into more of the central valley of New Mexico. Let's look at Los Lunas. So this is at the Agricultural Science Center. And so same time period, July 1st through yesterday. And so the precipitation for that period was 3.68 inches. And that's 3.4 inches below average. So we missed out on more than 3 inches since July 1st. And that's a lot. So you can see the gaps. So there's been some really dry periods in the summer. We've had a really dry August, and then again in September through the beginning of October. And then it's pretty much, we've had very little precip at all in the fall. And so we kept accumulating more and more deficit, meaning we're drying out, and just sort of translates into really dry soils and wind erosion and things like that. So and so last year was also below average. It was 5.66, and this year even worse. And not much help over the last 30 days. This last month, only 0.22 inches. So let's move a little further. I'm going to show you this one station here. So this is if you go into pretty much like the southeast part of the state, just to show how deep the drought is that we're seeing. So same time period, same kind of graph, the long-term average, and then here's the trace of the precipitation. So pretty much they had one significant rain event in August, and that's it. They have a few small events, but pretty much they're like 6.53 inches behind for that time period. That's a lot. And that actually, well, when I show the US Drought Monitor maps, you'll see why you're seeing the the really dark red colors of the worst drought. So this is right in the smack in the middle of that area. So you can see that's the kind of indicator that we look for. We don't want to see that. We don't want to see any of these kind of things, but this is what when a drought delivers things like that to us, we've got to report it. So only 2.13 inches since July 1st, just about 8.5 inches last year. So not looking good. So let's go back up toward northern New Mexico. So let's look up Dulce. Same time period again. Total precipitation since July 1st was 9.18 inches. And even that's 3.3 inches below average. And we've had a little more last year, 9.9 inches last year, but still for this time period, we should be around 12 and a half inches. So last year was below average, and this year is even more below average. So you can see that long-term deficit that carries over year to year when we have a low monsoon, as well as we don't get caught up in the fall. So that has implications for our vegetative stress. If we're not getting soil moisture down to the root zones of trees, so and as well as the kind of the annuals and things like that are out there and forage for wild animals as well as the livestock. So there's a lot of implications for having multiple years and multiple seasons that are below average. So let's look further into the Four Corners. So this is Farmington. So this is on the south side at the Agricultural Science Center by Nappy. So total precipitation for that period, July 1st through yesterday, was 2.79, and that's 3.09 inches below average. And it actually is the driest on record. They don't have a really long period of record there, meaning they've been collecting data. They've been collecting it quite a while, but not as long as some of the other stations that have like 50 years or 100 years. But for that station, it's the driest they've ever measured from July 1st through February. And on top of that, if that wasn't a kick, that last year they had 3.21 inches, and that was the third driest. So think about that. Just think 2 years in a row, and 2 monsoons have been really non-producing. So you can see that deficit. So they're behind so far 3 inches. So I mean, they've had a little bit of precip, some snow and some rain over the last 30 days, but it's only a half inch, and we really need that 1 inch. We need several of those to occur, and this is that event right there. You can see my highlighter, that half inch of precipitation, which is great. We'll take every precip event we can, but we need more of those to come. And right now, it's not in our future right now. We may get a few, but I don't think we're going to make up that 3 inches. It'll probably take a while. So let's go a little further west. There's a weather station at Cannon-de-Chelly. So same time period. There from that time period on, they've measured 3.24 inches, and that's 3.57 inches below average. So they've been missing out. And last year, they've only had 4.88 inches. And so compare that to what the long-term average is, just shy of 7 inches. So think about that. We've had a few rain events. We've had some snow. That's this right here in January. But other than that, we've had some really dry periods where no precipitation. Really dry September, dry beginning of August, most of August. So the main story is not only the lack of moisture, but the warmth. So there's a lot more evaporation, a lot more evapotranspiration. That's the loss from the plants themselves. And so that's a cause for concern. I mean, now that things are in hibernation, things are waiting for, but we're basically putting in our bank right now the soil moisture. We really need that precipitation. We prefer snow, but if we can get rain, we can get that soil moisture to go down to the lower several inches. I was looking at some of the data in Colorado, and they've been getting some decent snow, but they're in a few areas there. They were actually, this is in the mountains Grand Junction area and that over in the mountains there. And there it's more of like the soil column was pretty dry and down to about a foot. It was it took about a foot before you get down to any moisture. So if you look at the US Drought Monitor maps, you can see why we're painting those colors very dark red, because they pretty much a really dry soil column. Okay, so let's look at the snowpack and several basins. I just pick a few of the basins. So this is the Rio Grande Basin. And so these maps show the entire water year. So it starts out on the left side here on October 1st. And so the black line is the actual, what they call snow water equivalent. So that's how much liquid water is in the snowpack. It's not snow depth, because snow can be, you can get like powdery. So we don't really count how deep it is, but it's how much actual liquid is in the snow. And so we start off not too bad, and we've accumulated pretty much near the green line, which is the median. So that's if you think about the math, that's 50th percentile. That's right in the middle of the data sets. And then the red line here, that's the worst case, and then the blue line is the best case, the wettest snow. So we've been hugging that median for a while, and but we've missed out on a lot of storms in December and also in January. However, we've got a nice uptick here recently that bring us up pretty close. So we're like 89% of the median. So, but it's still drier than we like right now. So there's still, and this is the high elevations. So remember, these are the weather stations up there. So they're automated stations that measure the snow water equivalent in the high elevations. So they provide the water that in the springtime that brings and fills our reservoirs. So this is our bank for the rest of the year for a lot of our agriculture. So let me go to a different basin. So this is the San Juan Basin. So same story in the beginning of the season, beginning of the water year, we were pretty much following right along the median, but we missed out on a lot of storms. So a lot of the storms, and we'll talk about this a little later, we're in this La Nina phase of the El Nino Southern Oscillation. And so La Ninas tend to, for most of the time, we get a lot of the storms will follow a more northerly track. And so the tracks are further north. And so we follow along pretty much the median, but we missed out a lot. And we've had a couple of time periods where we didn't get any snow at all. So that's what this horizontal line, we don't like to see those at all. But here's our uptick that we saw in the Rio Grande Basin. So this uptick here bring us up, but we're still below the median. We would want to really see that go above the green line here, but we're not doing terribly bad, but it's not good. We've only 81% of the median for San Juan. So if we go further east, southeast to Pecos, those are where we're seeing the majority of the problems here. Here's a black line where we are, and we really missed out on a lot of the storms, and it's been warm, and so it's pretty much flat up until the beginning of January. And here's that same uptick recently. So they've gotten a little bit of storm, but it's more in the 10th percentile. Right now it's currently at the 8th percentile and only 38% of the median. So we got a long ways to go if we even need to get a decent snowpack there. And it may be too late for that. I'm not sure, but that Pecos doesn't look good. I was hoping to get the data from the Chusca snowtail stations. There's two stations on the rim. There's the Beaver Spring, which is an Arizona side, and then the Whiskey Creek on the southern, a little further south. And so I was able to pull these precipitation. This is the liquid amount of precipitation these are two automated stations there, and goes from, this is the beginning of the water year. So they had 7.3 inches at the Beaver Spring station and 6.3 at the Whiskey Creek. And I was comparing this to the previous years, and because I was looking at the US Drought Monitor to see where we were looking at. And actually, if you look at the far right, you can see this uptick here. That's the same uptick I was showing in the snow water equivalent and all the other basins in Colorado and northern New Mexico. And actually it was they've been this is one of the driest years we've seen. If we didn't get that, we would have been in really bad shape. And we were looking at that, and we've seen some good snow. So if you're in that area, let me know how much snow you got. Love to see, or even pictures of what it looks like up there. But we've seen several inches of liquid accumulated in the past few weeks up there. So that, which is good sign, but it's still really dry. So think about it. We've gotten a small amount of moisture, but we have really dry soils all the way through the whole water year. So I guess it's sort of good news because we got that, but we need more of these storm events to add to the snowpack up there. I know there is some of the hydrologic basins up there. They're pretty dry over the past few years, and so this is what we're seeing. And I like to show these maps. I know it's a more zoomed out picture, but I just kind of compare 2 years. So on the left side is this time last year, so February 2020, and on the right side shows February 2021, pretty much right now. And so this is a map that's put together by the National Snow Analysis of NOAA, and it basically shows the snow water equivalent in units of you can see the coloring on the bottom. So it goes from white is 0, and then the light blue is about 0.2 inches, and it goes to the kind of the deep purple is like 3 inches or so. And so you can see that where the high elevations, we're very close in terms of the coverage for last year. And I was pulling together some statistics. So right now that and this is the west wide. This is for that whole map. So which includes the Southern Sierra as well as Great Basin, Utah and Colorado. But it's sort of an informative to see that comparing different years. So right now the area of the west in this map covered by snow is 11%, and last year it was about 12.8. The year before 2019 it was 13.9, and the driest I've seen in the 20 years is 2018. We had 3.3%. So this time, February 4th, in 2018, it was really dry. It was very little snow. And it was amazing to go back and comparing 2016 and 2010. So remember 2010, it was we had a La Nina that year, a pretty strong one. And in 2016, we had 40.6% of that whole area, that map was covered in snow. And even better, in 2010, 45% of that map was covered by snow. So there was lots of big areas of most of Arizona and New Mexico were covered in snow on February 4th. And so we're right now, like I said, we're 11%. So a big difference in the amount of snowpack. So let me go from the precipitation coming as snow, and then we can see it reflecting into the stream flow and into some of our rivers. So I just want to show 4 of these stream gauges. I know there's a lot of them out there. I just want to show four of them here. And we'll start over on the upper left, the Animas River at Farmington. And so these are the past 2 months. So they start on December 1st and go until yesterday. And so the squiggly blue line is the actual measurements from the stream gauge. And then the yellow, the orange triangles, that's the median. And for the Animas station, that's 97 years of data. So we can see and it's a log plot. So we're sitting at, just below 200 cubic feet per second. Whereas the long-term average was somewhere around maybe 260, 270 cubic feet per second. So we're below average there. So if we go to the upper right, if you go down to the Rio Grande at the Embudo station, same kind of plot, same time frame, 1st of December through yesterday. Blue line, and we were basically just below 400 cubic feet per second throughout that time period, and then long-term median was around 500. So we're about 100 cubic feet per second below that average. And then if you go to the bottom right, this is the Rio Grande in Albuquerque. We've had some releases in some of the reservoirs up north. So that's the ups and downs, and some of them are a few precipitation events. So we've been hugging around a little more between 500 and 400 CFS. We're the long-term average, which is 47 years. We should be around 700 cubic feet per second. So we're below average in that as well, going further in the Rio Grande. And then finally, over on the bottom left, the Pecos. So this is right above the Santa Rosa Reservoir, same time period. We're pretty much, the blue line shows 3 to 4 cubic feet per second, pretty much very little flow. Whereas the longer term average, I mean, it's just not much there. 10, 20, 30, maybe 40, actually no, 12 or 13 CFS, 14 CFS. So we're pretty much, and this is kind of the story. If you look at a lot of the hydrographs all over, all in the Four Corner states, actually, below average, a few spikes of it kind of goes up to the median, but then we see that going back down to the longer term average, below the longer term average. So let's look at some reservoir storage numbers as of February 2nd. This is from the Bureau of Reclamation. Just looking at the Rio Grande and Pecos basins. So starting off on our largest basin on the Rio Grande, the Elephant Butte is 8% full. So we got about 158,000 acre feet of there right now. And if you go down to Caballo, it's 13% full. So we pretty much drained those out this irrigation season, and we're bringing water in, but it's still pretty low. I was out there a few weeks ago, and I just looking to see if you can see some of the structure on the bottom of the reservoir compared to when it was, in 50% or even 20% full. So, and if we go into the Pecos down here, Sumner is 47% full. Down in Brantley, down near Carlsbad, 28% full. Avalon, 52% full. So not a lot of good. It's a smaller, less water on there, so there you can easily make up for some precipitation. Whereas the Rio Grande, it takes a lot of snowpack to build up storage. Look at all the available water that we need to have in here. So let's look further north. So up on the northern part in the Heron is 13% full, Elvado 12, and Abiquiu is 37% full. So as you can see, the impacts of our drought is hitting even our northern reservoirs. And if you go to the upper Colorado, some of these up here, even some of these larger reservoirs that have over 3.7 million cubic acre feet, they're only at 84%, even up there in the north, whereas down further on the Colorado, Lake Powell's at 40%. I didn't show Mead, but it's still very low on the Colorado. If we go further on the east side, Blue Mesa 48%, and then Navajo Reservoir is at 63% full. And remember, that's the capacity of almost 1.7 million acre feet, and we're about at 1 million right now. Okay, so I just wanted to show you some numbers. We saw the graphics, but I think we'll make the presentation available if you want to see the numbers. So this is we produce this every month from the Office of the State Engineer. We have for New Mexico, we have a drought monitoring work group, and this is one of the products that we have, and we have a website that we archive all these. It's every month we generate this graph of the storage on the Rio Grande and the Pecos. So this is kind of a summary, as well as the Canadian. So this kind of gives you some numbers of the current. This is as of a little bit old, but not too bad. January 21st, you can see comparing some of the current, these are in acre feet, thousands of acre feet. So some of them, you can see comparing this number is much less than last year's. So like in Heron, we're at 53, and last year we had 106,000 acre feet. Elephant Butte, but last year at this time we were at almost we were about 557,000 acre feet. Right now we're just breaking 100,000. So you can see that the impact of the drought, the lack of snow, the warm temperatures have played an impact on our surface water availability throughout all the basins here. So I just want to show you a few more things. So drought impacts, I like to look at soil moisture. And so we don't have a lot of measurements, but we have some models that we use. This is from NASA, that they run a model for the Southwest. And they do this every day, and they compute a 1 month change. So I like to see if there's a snow event, how much of a difference does it make? And this is, of course, this is a model, but it basically gives you a sense of the relativeness of the one storm, how much it impacts. So if we see a lot of greens and blues, that's good. And we don't want to see any yellows to reds, because that's the percent change. If it goes into the yellows, that's like a 2 or 3% change. And the blues are good. We want to see that. Those are like 10% positive, more wetter. So this is a 1 month difference. So from yesterday for the previous month, how much has it changed? 1 month difference. So we've seen a few areas where we've seen this area here. Remember I showed you those hydrograph, not hydrograph, the weather plot of the precipitation in the Chuscas. So there's a positive change in the soil moisture from that. So that is some good news, as well as in the right above Santa Fe in the northern part of Santa Fe County, in Rio Arriba County, into some good snow there, some precip in Sierra County, and so a little bit in but it's been pretty dry. As you can see, there's been a pretty much 0 to dry, in most of the Southeast, and that's kind of the story. Looking at the six month difference, so that's kind of where we're seeing the impacts over a longer period. We've gotten some short-term moisture, but over the long period, we're seeing some, looking at these numbers here, 4 to 8% change in the negative. So drying. So we've seen some of those areas. The snow is impacting. Those we see those in the 6 month. So here's our Chusca Mountains in Valencia. But most of all areas, even in the Northeast and over the west part of the state, has been very dry in soil moisture. So I also look at, so how did we end our growing season in terms of vegetation? This is one of the satellite-based model assisted vegetation index. And so I compare the end of this growing season right around the end of October, and then compare that to the previous year. And so as you can see, the legend on the right, darker reds, more extreme drought impacts. So extreme, severe, moderate. And you can see just the coloring. You can just see the coloring here, just to see just a sense of the drought is deepening since 2020 compared to 2019. There's been a few areas that were even dry. And remember, I said we had a bad, kind of a lackluster monsoon in 2019. Same way with 2020. It's sort of that long-term dryness out, and we're seeing that. So this is kind of what's out there now. Is after this. I mean, it's thinking about the impacts of not having a lot of precipitation for 2 years, and then when we go into the spring, when we get germination, warmer temperatures, maybe some precip, what is out there now for forage? So that's kind of one of the takeaways is, there's not a lot out there for animals, and as well as the soil moisture column is very dry and doesn't bode well. And so this is one of our products that we do. This is is part of COCORAS, and COCORAS is the Community Collaborative Rain, Hail, and Snow Network. And so as a member of COCORAS, which is easy to do, it's basically you measure precipitation in your backyard. And so as a member of that, you can submit condition reports. And so these are the condition reports from our observers. These are all volunteers. And so you can submit in areas. So each of those little triangles are individual observations from folks. And they've put in, what does it look like in your backyard or in your property or in your area, your community? And so I like to see those come in from people who know their area the best. And so it kind of gives me a feeling of, say, okay, that we have the drought monitor, so that's the background color is the drought monitor, to see where the impacts of drought are the worst. And when people show me when they submit the condition reports, that gives me a sense of, yeah, it really is dry there. Or if there's condition reports that are in an area that doesn't reflect the what the drought monitor is, I need to go and follow up. So like that area down near Hillsborough, down here. So I need to follow up on this. Like, why is this in the moderate drought? We have it only painted in the yellow. So that's kind of a sense. That's kind of what I do is look at on a weekly basis what has come in, and then reassess what's going on. So our report, one of our observers in Gallups, and it was mildly wet over the past weeks, and this is from January 29th through yesterday. So it gives me a sense of where things are right now, and you as individuals can submit this information if you're a COCORAS observer. So I just want to make a plug for that this is how you can get information. Go to the website, sign up, and then I get to see this map and then show it to the other people, the drought monitor folks, and say, okay, yeah, we're seeing these areas, these communities impacted. Here's the proof. And then we overlay these maps and send it off so I can give a better estimate of where the drought is and where it isn't. Where are we seeing improvement? I hope to see improvement, but that's where we are right now, is we're seeing really heavy drought impacts in the northern mountains, most of the Four Corners. This is the only area. This area we converted from D3 to D2 just recently because of that snow. However, we'll be keep monitoring that. If we don't get a lot of snow, this could go back into D3 again, depending on where we what the snow looks like. So this is our current drought map. I'm sorry I didn't show the other states, but this is of New Mexico. As this is today's map from the U.S. Drought Monitor, and remember it's ranked by these different droughts. So D0 is the pre-drought. So there's 4 levels of drought, 1 through 4. And they're basically by percentile. So the worst case drought, the D4, we do this by percentile, and so if it's in the 0 to 2 percentile, that's when we start to look at the exceptional drought. So if you rank that, say that 1 month of precipitation, and we put all the 1 months, say all the Januaries that we've been collecting data, and we rank them, and if it's in the 0 to 2 percentile of all those years, then we can say, okay, that's in D4. Or if it's in the 3 to 5 percentile, we say, okay, that's more like a D3. And similarly for D2, it's 6 to 10 percentile, and D1 is 11 to 20. So that gives us a sense of how we make these maps. They're not automated. They're done by hand, and we look at all the weather stations, and we do our best to come up with a percentile or ranking. And so we rely on observers to tell us what's going on, satellite observations, as well as measurements of precipitation, snow. And we also look at things like forage levels and fires and things like that help us to gauge the impacts of drought, or even insect infestations are another one, as that kind of gives us a sense of the trees are drought stress. They're more susceptible to insect creating problems. And we can see that when we see the insects, we can actually see that in the satellite products. The vegetation becomes less green over big areas, and we can see it even though you can't see the insects, but we can see the impacts of the insects, especially even in the pines. We saw that this year. So why are we seeing this this trend? Why are we seeing the lack of the storms? So we're on the left side is what we typically call the La Nina pattern. And so we have the jet stream that comes off of the Pacific Ocean, and we have the two jet stream. We have the Pacific jet stream and then the polar jet. And so during the La Nina, the Pacific jet gets pushed further north. During an El Nino, the Pacific jet goes more further south. So right now, the Pacific jet is pushed further north, and so which means that a lot of the storm tracks will follow a more northerly trajectory. So they're mainly going up north. And I showed you on this right. I know it's a lot of colors and crazy colors, but it basically shows you the wind speeds at the jet stream level for the month of December. And so how extraordinary or ordinary was December winds and this is at the high level. So this is like, at the jet stream level, this is nothing to do with the ground, but the jet stream level where the winds below average or above average. And you can see over the continental US, there's this purple and blue that shows us it's below average. So the jet stream actually was much lower in December over the US, but it was higher in this. Here's the green and yellow. The jet stream, the level winds were higher up here as well as down here. So a lot of the storms went further north. So they actually had above average jet stream winds out over the Pacific into Canada. So a lot of the storms were moving out here. So a lot less. So this is kind of an indicator. It doesn't show everything, but it kind of gives you a feeling of yeah, we've been missing out. We should have been getting these storms over New Mexico, Arizona, the Four Corners, but they've been pushed further north. I mean, we've been getting some of them recently. Remember that uptick that we've been seeing the jet stream move further south. We got a kind of a taste of what we should get when we get that uptick. But then we're seeing like right now that the jet stream is moving a little further north. So we get a lot, and that's kind of the pattern we see for these La Ninas. So La Ninas, typically further south you go, the drier and warmer it is. And then the more further north you go in the US, the more chance of getting wetter and cooler because of the jet stream, the tracks of storms. So this is kind of what's going on under the hood. Why we're seeing these storms, why we're missing out is kind of this pattern here, and we're stuck in it. And I'll talk a little bit about the outlook in a minute. So this is the driver for the La Nina. So you have to go all the way out in the Central Pacific. And so this map here in the upper right is the Pacific Ocean. So here's Mexico over here, South America. And so this is the equator. So over here is Australia, Papua New Guinea. And so we're seeing this area of the Pacific is an indicator for what the weather patterns. It basically helps drive the location and drives our jet stream. So we need to look at this area to tell us what's the temperature of the ocean compared to average. And so right now it's cooler than average. And so we see this blue, it's below average, these color here. So that's the average sea surface temperature. That's what SST stands for. So we compare what it is now, this last week, compared to the average, and it's actually minus 0.7 degrees Celsius below the average. So that's in the category of a La Nina. So if we like to look at different little areas of the Central Pacific, and this one of them that's more indicative of the weather is this one is we label the 3.4 region. And so if we do a time trace of the sea surface temperature in that 3.4 box, which is right about, if you draw a box right about here, so that's what this graph here is. And you can see we were warm in the spring of last year, and we've done a deep dive in terms of temperature and cooling, and it bottomed out right around November, and that's when we really said, okay, we're in a La Nina. We're down there. We're pretty cool compared to average, and so we're going to stick, and that's going to trigger La Nina for our whole system, and it's been below average ever since. And so that kind of gives us a flavor for what's going to happen for the weather in North America. And so the Climate Prediction Center and Columbia University have teamed together, and they put together these probabilistic forecasts. And remember, we're not forecasting actual precipitation amounts or snow, but it's more of the the probability of this La Nina thing to stick around or go into a neutral phase, which is in between, or a El Nino. So there's 3 different phases, and that's what the different colors are. The blue is a La Nina, which we're in right now. The gray is a neutral, and then the red is an El Nino. So that's what we do it by these 3-month blocks. So right now we're in the December, January, February. So right now it's 100% La Nina probability. If you're a betting person, we're in there. It's a sure bet. As we get further into the winter time, the probability starts to go down. So in the January, February, March, it goes down to 95. February, March, April, it goes down in the 70s, and then the La Nina goes down to like 55% in beginning of March into March, April, May, and then the probability of a neutral starts to pop up. So the probability actually starts to exceed the probability of the La Nina. But the big story is that the La Nina is going to stick around for a while. So unfortunately, for us, for the Southwest, that basically says we're stuck in a La Nina for the rest of the winter and early spring, and then it's going to transition to a neutral, and then it's too early to say what the summer is going to be. I don't think anybody's going to put any votes in on the summer yet. It's too early. It's really hard to forecast through the spring because there's not a lot of drivers. It's not like there's not a lot of things that tell us it's going to be a wet or a dry summer yet. So I won't venture in that area, even though the maps the models will show you that, but I'm going to just stick with what's going to happen through the spring. So these are more for sure. I'm going out maybe 3 months. So it's not painting a good picture. Although the picture is a little better for a neutral than it is to keep another La Nina. So I'm hoping that it'll flip to a El Nino. We'll see. I don't know if that's the case. But here's I'm going to transition the talk into the kind of outlook and forecasts. So I just downloaded this map this afternoon. This is the basically the QPF is a quantitative precipitation forecast. This is the 1 week. So it starts off today and it goes through the 12th. So Friday to Thursday to Thursday, basically. And so not a lot of help. The higher elevations in the Colorado Basin are probably going to get some precip, but not much in New Mexico. Maybe a 1/4 inch. A few higher elevations, maybe we'll get maybe 1/2 inch, but maybe some snow, but not a lot yet. So not unless you're over here in the Cascades or up further north, you get snow, but not much for us in the next week. Looking out through the 13th of the month, the left side is the temperatures. So it's, it looks like we're going to get a cooling down in the plains in the Midwest, probably in Arctic, and they're going through some others oscillations, but they don't typically impact us too much. But that it does bring in some cooler air masses that cool things down, which is good. We don't want to melt off any of our snow, which is a good thing. Even though we may not get much snow in the southern part of the state, there's at least a chance in the northern part of the state in through the second week of February. Going a little further out to the 8 to 14 day outlook, same story with the temperatures below average, which is good. And however, we're seeing that dry period extend out. So the probability of any precipitation is decreased. The probability for below average precip, that's what the right side map is precipitation probabilities. These are just probabilities. They're nothing to do with the amount of precip, but it's 40% probability of a below average in the western half of New Mexico and all of Arizona and the southern part of Nevada and southern Utah. They're going out to 3 to 4 weeks from now. This is going toward the end of February. It's basically showing the more of the flavor of a La Nina, below average precipitation and above average temperatures. So see all the way from the Pacific Northwest are showing actually, and even to the coastal states, below average precipitation. Only places that they're showing that above average precip is up in the air in the northern plains and the Ohio River Valley, but warm for the southern states and cool for the northern states. Going out for just kind of summarizing the February outlook. On the left side, temperature, equal chance. It can go either way, but above average in the far south, and equal chance, which means there's not a lot of, can go either way into or below or above. This is for the whole month of February, but the probabilities for below average precip is in the southern New Mexico. Going out further, 3 months through rest of the spring. So February, March, April. On the left side, kind of our story, we've been seeing above average temperatures, specifically more for the southern part of New Mexico, but also, I mean, that's a 60% probability. It's pretty good probability of above average, and 50% probability for most all of New Mexico and most of Arizona. And then the more bad news we're seeing on the right side is the probability of precipitation. So there's a 50% chance of below average for almost majority of the Southwest, going all the way from coastal Southern California, most of Arizona, and into the pretty much 2/3 of New Mexico. So I wish there was a better news on there. And if we want to go even further out, I don't usually go any further than this. This is going out to about 4 months. A little more than 4 months, but it's basically the same picture. It's basically saying that the La Nina is impacting the storm tracks well into the spring. That's kind of what these maps show me. Basically saying that the above average temperatures are still in the southern tier states, Southwest, and then seeing that there's more of a below average precipitation for all of Arizona and New Mexico, and into higher, not as high probability, but still pretty low for all the southern Great Plains, as well as most of parts of the Great Basin. So, and even Florida. So that's kind of the furthest I'll go in the outlook is basically showing the same thing. We may get some storms come in. There's a lot of other short-term things that go on in the weather patterns. There's these things called the Madden-Julian oscillation, and so that those kind of kick things in, bring in storms, but overall the storm tracks are the bigger drivers of the Pacific storm track system are showing this kind of pattern. There may be some variations, but we may be surprised to get some precip, but I would in terms of planning, use these maps as a planning guide for, this is what the spring's going to be. We don't know what the summer's going to be yet. I won't venture a guess yet on that, but be prepared for the rest of the winter and spring to be pretty dry for the Four Corners area. And as such, I think this is my last slide or so. The seasonal outlook for drought, and this is released on January 21st. All that chocolate covered brown, that's the drought persisting. So I mean, pretty much is almost the majority of the Western U.S. and the areas that who have drought now are going to stay in drought, and a few areas that are in the southern Great Plains that are sort of dry and not so bad right now, but they're saying that's the drought development likely the yellow. So even the Panhandle, Texas, Oklahoma, into southern Kansas, drought is probably going to rear its face again here, but we're stuck in drought. So that's kind of where we are. I wish I had better news again, but we're really hoping for El Nino someday to really sock it to us and give some precip, but it doesn't look like that right now. So, oops, I put a wrong thank you slide. It's from this other talk I had, but let me go back to the first slide. So I'll end the talk right there, and then we can entertain any questions from the audience or any other participants. Thank you.
Okay, thank you, Dave, for that presentation. We're going to go ahead and give the floor to the attendants to see if they have any questions. If you have any questions, you can either raise your hand or enter your question into the chat box.
You guys are pretty quiet. I guess that's a good thing. And if you think of a question later, feel free to contact me. I guess you can send it through you guys, you can forward it to me and I can respond back. I'll be glad to answer any questions now, but if you can't think of any, or if your tongue is tied, that's fine. We can chat on email. That's good too.
We have a poll that we would like everybody to go ahead and take. It only take about 1 minute. So go ahead and start the poll.
Okay, the poll is up, and then we do have a raised hand. Sadie?
Yeah, I have a question. I noticed in your Kokoras you had like only a few people, and what we would like to do as a NAPS project is to have our producers become more engaged and be able to do the Kokoras. Would you be able to see more of those triangles then? I'm surprised that you didn't have very many.
Yeah. So I would love to have folks help out with this is the Kokoras gauge. So to join, all you have to do is go on to the kokoras.org, COCORAHS.org, and you can sign up and then get one of these gauges. They vary in costs. I think you can get it on sale for like $35 or $40. And then all you have to do is listen to some training. There's a webinar, or you can go online, just look at it, and it's pretty easy to do. All you have to do is measure how much precipitation falls in this inner cylinder. This is the funnel, and you do that every day and report it to the website. And as a bonus, I put in that condition monitoring. So that's as a member of Kokoras, you can join that condition monitoring. And so there's a select number of observers who do the condition monitoring. So that's why there's only a few little triangles on that map, because not everybody who does Kokoras will submit condition reports, but we'd really love to see more of those. And so you contact us if you want to get more information on Kokoras, and because those are really helpful to us to say, yeah, it looks really bad, or it's like, yeah, I'm starting to see some things come up, or just anything at all about drought or how wet it is or dry, which is very helpful. And I would love to, if there's anybody who would like to do a training thing, I'd love to do that too. We could work with you guys. I know Helena has done some training. I know it's more another Zoom meeting, but that's the way things are now, to kind of get you up to speed on how to do the measurements and then the condition monitoring. So think about that.
Okay, we have another question from Ernest Deswood. How do we monitor our soil moisture?
That's a great question. So how do we measure soil moisture? So there is, as part of Kokoras, there's actually a soil moisture protocol. And protocol is just instructions on how to measure soil moisture. You can do that as a citizen scientist, and it's pretty simple. I won't go to all the details in that. That's on our website. I mean, you can get a sensor, fairly inexpensive, that you can put into the soil, and then it measures the percent, the amount of moisture. Those are helpful too. They're a little bit expensive, but those, it gives us a sense of the relative amount of soil moisture, and you can put it into a really wet soil and measure it, and then put it into a completely dry. Put it in your oven, bake all the water out of it, and stick it into another pot of soil, and it should give you the 0 to 100%. And so you can calibrate these sensors on your own. That's a quick and dirty way of doing it. But you can even feel the soil. A lot of, if you kind of know what a wet feels like, it depends on the texture. You can feel the soil. So it really helps to have, you can even talk to somebody who's an expert and have them guide you on, so what is sort of wet, go down, 12 inches and dig a hole and then feel the soil. I encourage you to do that. I do that when I travel. I go out, I bring my little shovel with me, and I go down about 12 inches and I say, is there any moisture at all down there? And so that gives me just a relative. I don't know anything about the soils, but it just gives me a gut feeling. It's kind of like when you're digging post holes, you know, how far do you have to go down to see really dry or wet? So those are some, it's more of the non-scientific ways, but and there are ways scientifically to do these, and it depends on how much effort you want to do. You know, soil moisture, as well as, you know, you can, if you have a balance and scale, you could measure the volumetric moisture content, but it's a little more work that way. But that's how we do it in the field. Hope that helps.
Okay, another question from Ernest Deswood. Can we set up location monitoring equipment, and what do you recommend?
It all depends on first of all, what do you need to measure? Precipitation or soil? If you want to do precipitation, this is the easiest way to get started. It's the least amount of effort, the cheapest, you know, $40 to get you going, and then it goes into a national database. If you want to invest more, a personal weather station, you can get started around $500 for one. I know it's a little high, but you know, save your pennies and invest in, and you can get hourly data, precipitation, temperatures, humidity, wind speed, wind direction, pressure. You can set those up, and they're very quickly. If you need more, you know, let me know. I can answer, you know, in terms of the, you know, just adding more sensors and, you know, even soil moisture. There are soil moisture probes that you can connect to a weather station, and you can get hourly soil moisture or hourly soil temperature. And a lot of times we measure at all of our weather stations the soil temperature at 4 inches down to give us a sense of the, you know, if you're looking at cropping, you know, when the seed, a lot of times the temperatures of the soil makes a difference. So those are some of the things that you could do. It's simple as getting a thermometer and measuring it every day. I mean, I did that as a child. Measuring it consistently every day in the shade gives you a sense of the temperature variations, and then look at it compared to somebody else's measurement.
We got Dave DuBois' email in the chat box. If you have any questions for him, you can go ahead and email him.
Yeah, and if you ever anybody needs more guidance on weather stations, on what kind of things to buy, just shoot me an email. I've got a handout that I could send on some suggested instrumentation that's low cost. So just let me know.
Okay. All right, that concludes our webinar. So please join us for our next week's webinar at 5:30 Mountain Standard Time with Mike Crimmins from the University of Arizona. And Climates will be presenting about monitoring participation and rangeland tools, strategies, and best practices. The goal for the NAPS project is to increase the probability and long-term sustainability of Navajo farmers, ranchers. To achieve this goal, activities for our 4 keys are being undertaken to improve Navajo farm and ranchers' operation, increase Navajo farmers, ranchers' knowledge and access to available programs, technical assistance provided by the United States Department of Agriculture, the BIA, and the Navajo Nation, and the New Mexico Cooperative Extension Service, and the Dene Club Land Grant Office, and others. Facilitate Navajo farmers, ranchers' use of USDA Natural Resource Conservation Service, Farm Service Agency, and Risk Management Agency programs to strengthen the organizational capacity of the Navajo Farmer and Rancher Congress, also known as NFRC, to address the current and future needs of the Navajo farmers and ranchers. Okay, we'll go to the next slide. We welcome your comments so that we may provide resource and interest to better farming and ranching methods. We continue to host and post information on our Facebook relating to our upcoming events, including our monthly newsletters, how-to videos, USDA resource, and links, and recorded webinars will be posted on our Facebook, YouTube, and we have a website incoming. Once we get that up and running, we will go ahead and send out a URL. You can find us at Native American Producer Success Project, NAPS. Okay, that concludes our presentation for today.
Thank you everyone for joining us, and thank you, Dave, for your presentation.
You're welcome. Glad to be here.
Thanks, Dave. Thanks for everyone for joining. Bye.
Bye.